Let me share my screen. So last class we have seen till abstract class, right? Abstract class members. Okay, we have completed with the abstract class. Next is let us take an example. Test 160. If you have any question from previous class, you can ask anytime. So what we have seen so far is in case of dynamic dispatch, okay? In case of dynamic dispatch, so we have class A and class B. B extends A. A is having a method void show. We'll write implementation. And this is show method in A class. Right. Show is inherited and overridden in class B. Okay, and it is having a new method disp. And now disp method in B. Disp method in B class and show method in B class. We'll use dynamic dispatch. A1 and new B. Okay, B. Now to call the method, in case of dynamic dispatch, we have seen how it calls. Verifies the signature in superclass and calls from the subclass, right? So this is A1, creating an object of type B. This is pointing here. Say address is 1040, so this will be 1040, right? Now in the main method we have these things. Now if I call a1.show, so signature will be verified in reference type, right? Reference type is which type? A type, and it will call from the object type. So if you say like this, a1.show, it works fine, right? It will be fine. So the output should be show in B. And once test 160, compile it. Java C test 160.java. Execute test 160. It works fine. Now, if we try to call the newly implemented method in B class, which is disp, a1.disp, it will be a compilation error because the signature is not available in reference type. Signature is not available in reference type. So it is a compilation fail. Where is the error is a1.disp when you call, verify the signature in reference, cannot find symbol, right? Compilation failed. Compile once and see the error. Cannot find symbol disp. So in this type of scenario, we have used dispatch, dynamic dispatch so many places like abstract class, interface, right? All these things. So newly defined method you cannot call from dynamic dispatch. What will happen now? How you will call? Say the requirement is like this, and I want to call the newly defined method. You notice here the object is this object. Object is of type B, right? So we can have a reference variable of type B, B1, and it can point to this object because object is of B type only. It is okay, right? So what we need to do? We need to convert this reference variable to B type. Conversion is simple. We have already seen typecasting. So what you can do, B1 is equal to new B, not new B. A1 we have to typecast. A1 we have to typecast to B type. Okay. A1 we have to typecast to B type. Now, how it is? We have created another B1 reference variable which is 1040, and that is also pointing to the same object where A1 is pointing. Two reference variable pointing to the same object, A1 and B1. And now this is no more dynamic dispatch. This is not dynamic dispatch. This is normal reference variable and object is of same type. So now if we call B1.disp, it is okay. Compile and test. B1 test 160 cannot convert. B cannot be converted to A, cannot be converted to B. Incompatible type. Why? We need to convert to B type, right? B type. Typecasting is this one. Okay. Now, okay, and execute. Test 160. This is working fine. This is calling from B. So this is now not dynamic dispatch. This is normal, okay? So newly defined method, if you want to call from the subtype, the reference variable has to be converted to be subtype. And after conversion, it will not be dynamic dispatch. So method signature will not be verified in reference type. It will become static binding now. Right, at the time of compilation where compiler points that this method, JVM also calls from the same location. It is not going to change. It is not dynamic dispatch now. So this is how you will call the newly defined method from subclass if you are having dynamic dispatch. Okay, so through dynamic dispatch, you can call only those methods which signature is available in reference variable. Newly defined method you cannot call from the dynamic dispatch. You need to typecast it to the subtype, and then only you can call the newly defined method. But it has a problem. What is the problem? Problem is the class reference is how it is here. A is the superclass A, B is the subclass, right? Reference variable is of type A, A1. A1 is the reference variable which is of type A. Now, inheritance relationship we have already seen. A1 can have an object of type A, new. A1 can also have an object of type B. For the first statement, this one, it is not dynamic dispatch, but for the second one is a dynamic dispatch, right? So possibility is there that A1 can have an object of type A or A1 can have an object of type B also. Both is there, chance is there. Currently, we are doing here A1 new B, that is we know. What if A1 is having an object of type A itself? Okay, if this is the scenario, then in case of typecasting, we have seen, say int x is equal to 10 or you take this one first. Byte b is equal to 10 and int x is equal to b. No problem, that is fine. Because b is of lower type and x is of higher type, right? Higher to lower, you can directly convert, no problem. Implicit typecasting. If it is reverse, int x is equal to 10 and byte b is equal to x, this is not okay, compilation failed. Explicitly you have to typecast. Means from higher type to lower type, when you are typecasting, there is a chance of losing some precision. So you have to do it explicitly. Directly, implicitly, it will not work. Come back to our point. A1 is having a B object, so typecasting to B is fine. Because A1 is higher type and converting to lower type. Object is lower type, converting to same type only. So this is okay. What if the object is of A type and we try to convert to B? A to B. Means what you are trying to do, you are saying that B1 is equal to new of A, which is not possible. We have already discussed, starting off OOPS concept. A supertype reference variable can have a subtype object, but subtype reference variable cannot have a supertype object. That we have discussed so many times. So now, suppose this statement is like this, new A, and this I am putting into a comment, right? So now show will be called from A, that is fine. I'm trying to call B, but before that we are converting to B type. Means you are saying that a reference variable of B type should point to an object of type A, which never possible according to this, which is never possible, right? We cannot do it. So now if I compile this and run, it will say here typecasting is not possible, okay? Typecasting is not possible. Compile it, test 160. Okay, no problem. But runtime error, okay? It is a runtime error. Class cast exception. A cannot be converted to B because object is of type A now. And you are referencing to a subtype variable. Not possible. Not okay. Right. So in this scenario, this is not okay. You cannot do it. Remember this point, okay? Remember this point. You cannot do it. Supertype to subtype you cannot convert, but subtype to supertype is possible. Okay, remember this point. This typecasting is possible only when it is pointing to a subtype object. So in case of dynamic dispatch newly defined method, you cannot call. You can call only those methods which have the signatures in supertype, but will be called from the subtype. To call the newly defined method, you need to typecast that to subtype, and then only you need to call the newly defined function, right? So this is done. Come to another point. Point is, I'll take another example, 161.java. Assume the scenario is like this. We have class A, and A is having a subclass of B and another subclass of C. Okay, this is the relationship. Now, here you have a show method. This is overridden in B, show, overridden, and a new method disp in B. Okay, in C, show method is overridden, and a new method info defined. This is the scenario. Now, a reference variable A1, object I am not coming. Now suppose Let us implement the code till this. This part will not come. A and show method, B show and disp, C class. C class show is implemented, C, and it has a info. Info method in C, right? Take a reference variable A1 is equal to, say, new B first type, new B. And I'm calling show, will be called from B only, that you already know. Now I want to call disp. What do you have to do? If you are calling from disp from the B, then you have to typecast to B type, B1, B, and A1 and B1 dot disp, right? So this should work fine. Till this should work fine. What we did so far is the same thing. Test 161 compile. Test 161.java and execute 161. Both is calling from, and it is dynamic dispatch. Okay. Now, if I want to call show and info means from C I want to. So what we have to do? We have to convert to C type. C1 is equal to C type. We need to convert and A1, then C1 dot disp. Sorry, info. C1 dot info, right? Then info should call from C. But it has a problem. What is the problem? The problem is A1 reference variable of type A pointing to an object of type B. Okay, 1040. This is 1040. This is still first statement. This one done. Now you are calling show, A1 dot show. Show will verify in A and it will call from this, right? Then typecasting to B type. B1 one reference variable, and you are telling this A1 address has to go to B1. This means, right, after conversion, means this also pointing to this object. This is 1040. B1 is of type B. B1 B type reference variable, B type object, that is fine. A1 reference variable, A type object, A type reference variable, B type object, fine, because super type. Reference variable is of super type, object is of subtype. Both is fine. And after that, you are calling B1 dot disp. Come to this. You are taking a C type C1 and you are telling A1 should point to this, means these also should point to this one, means here A1040. Now object is of type B and reference variable is of type C. Object is of type B and reference variable is of type C. Now you see the relationship, these two class. Any relationship? No. A B reference variable cannot have C object, C reference variable cannot have B object. So this statement is not possible. Okay. So what you have to do when you are converting, this conversion when you are doing, this statement is not correct. This thing is not correct. You cannot convert. So if you try to convert here, we will get an exception again, class cast. In this case, we will get a class cast exception. For this statement, we will get a class cast exception. Compile it. Test 161. Okay, execute Java test 161. Class cast exception, B cannot convert to C because object is of type B and this cannot convert to C. So now this is a runtime error. You notice this compilation fine, no issue. Compilation fine. no error. So assume you have developed the application and you didn't notice that. You have developed the application and you did not notice. At the time of production, when the application is released or you are doing a testing at that time, you got a class cast exception in this case. Okay, this scenario will get a class cast exception. So you need to avoid any compile time exception is fine, but runtime exception is dangerous. You should not. Okay, you should write code where you should not get any runtime exception. If compile time exception is fine, when you're developing only will come to know that these are the errors and you will avoid those, you will solve this. Runtime exception, you don't know what will happen. And this is the scenario. Now assume this object I am creating of C type. Now where is the problem? C type reference variable, C type object, fine, no error. But what about this one? This also will not work. Because now again class cast exception. Assume this object is of type A. Now what will happen? A cannot be converted to B, A cannot be converted to C. Both is not okay because subtype reference variable cannot have a supertype object. So what you have to do in this case? Come back to language fundamental. In this we have missed one concept, that is operator. In operator we missed this one, instance of, and we told that we will discuss little later, right? This is now instance of. Okay, you have to use instance of operator to verify the which type of object it is. Now instance of operator is binary operator. Instance of lowercase, okay, lowercase. It is a binary operator, operand 1 and operand 2. 2 operand is required. Returns a value of type boolean, either true or false. A boolean value it will return. So what it verifies? Operand 1 must be a reference variable. And operand 2 must be a class name. Okay. Instance of operator is a keyword. It is a binary operator. 2 operand is required, operand 1 and operand 2. Return type is always boolean type. Operand 1 must be a reference variable. Operand 2 must be a class name. And what it checks? It checks that reference variable is pointing to an object of that type of class or not. If yes, it will return true, otherwise false. Okay, it is a verification. It verifies operand 1, which is a reference variable, pointing to an object of a particular type or not. If it is pointing, returns true, otherwise false. Now come back to our point, this one. This is fine. But what we do here, we check that before converting A1 to C type, we want to check A1 is pointing to an object which is convertible to C or not. If it is convertible, then only perform this operation, otherwise no. Clear, right? Instance of operator, task is to verify a reference variable is pointing to a particular type of object or not. It returns a boolean value if it is pointing, otherwise false. So now to avoid the class cast exception, before conversion any reference variable or object to some other type, we must verify that the reference variable A1, which we are trying to convert to C type, is actually pointing to an object of type C or not. If it is pointing, then convert, otherwise don't perform this operation. Clear, right? So what we can do, here, if one condition, A1 instance of C. If A1 is instance of C, then only convert it to C type and call info. And if is false, if it returns false, then if operation will not work. You know already that, right? If and else. If condition is true, control will come to if block. If condition false, control will not come to if block, and that is over. Now, if I compile this operation will not perform, and it will complete. No error. Compile again and execute. This is fine. Both is from B, and this operation is not performed. No class cast exception. So this is handled. What about this one? If it is C type, then this will be true. If it is C type, this will become true, and this will work fine. But here you are going to get a class cast exception. Again, same thing you perform here. If A1 instance of B type, if it points to a B object, then convert the reference variable to B and call this. Otherwise, convert to C and call info. Okay. Now check. Fine and execute. Now it is calling info from C because object is of C type, and this was not called. This was not called. Okay. This is instance of operator. Okay. Where instance of op is required? When you are typecasting. Why typecasting is required? If you want to call newly defined method from subclass. Right. Now, if it is A type, A, what will happen? This will become false. This will also become false. And what will happen now? It will just call show. From where it will call show? From A only. Convert, check it. Okay, execute. Fine, just show. Now from here, you need to remember another thing. You need to understand another thing. I hope you are clear with this. I am going to remove. If you're not clear, then watch the video repeatedly, okay? Important point. You are in inheritance relation A, B, and C, okay? C. In case of reference variable, we have seen superclass reference variable can A object, can B object, can C object, right? B can have only B, C can have only C. Other relation, if you want, you can take multiple classes in C, okay? Next is, whatever object we create for A, say A1 is equal to new of A, okay. If we check A1 instance of A1 instance of A, okay. If we check this will be correct, true. It is a new pointing to this object. If we check A1 instance of B, not okay. A1 instance of C, not okay. Clear, right? Superclass object only will be instance of superclass, like this. Now suppose B1 is equal to new B. And if we check B1 instance of A, it will be correct. B1 instance of B, it is correct. B1 instance of C, this statement will come. Not clear, okay? Not clear. We'll come back to this. Now, if we take for C1 is equal to new C, and C1 instance of A, correct. C1 instance of C, correct. C1 instance of B, will come back. Okay, so now what you understood from here, all the instances of subclasses are also the instances of superclasses. Okay, all the subclass instances are also the instances of superclasses, but superclass instances are not the instances of subclasses. Because of this reason, Now the same class only, right? I'll put all these things in a comment. This is commented out. Now try the below things first. These things, this what we written here, we'll try those. A1, new A, and I'll just take a boolean one flag variable. Currently nothing, okay? And flag I'll print. Flag will initialize here. A1 flag is equal to A1 instance of A. That's it, okay? It is a flag boolean variable. First statement. This statement only we're checking. First statement. Compile test 161. It should be true, right? 161. Where it is expecting. Okay. Here. Now compile. Okay. Execute. 161. It is true. A1 instance of A is true because it is currently having the object of A only. Okay. Next. Next is A1 instance of B will be false. Now this flag value should be false. Okay, it is reinitialized. Flag is reinitialized at this statement. Here it was true, but when it comes here, it becomes false. Compile it and execute. It is false. Similarly, A1 instance of C. Compile and execute. It is false. Okay, false. So this first A is finished. With A, all things are done. Try with B. B1, new B. And flag is B1 instance of A first time. B1 I'm checking instance of A or not. It should be true. All the subclass instances are also the instances of superclass. So it is true. Okay. B1 instance of B anyway will be true because it is B type object only. This will be true. True. Next, the last one will come back a little later. Try C1. C1, new C. And C1 instances of A should be true. Lowercase. True. C1 instance of C also should be true. C1 instances of C. Compile it. True. Okay. Remember that all the subclass instances are also the instances of superclass. Now, this part. When we are coming to A1 instance of B becomes false because this object is of type supertype. Supertype instances are not the instances of subtype. So this becomes false. Again, C, same thing. C is subtype. C is not having, cannot instance of supertype. Okay. So this is not correct. Because of this reason, these two statements are becoming false. If I take this of type B, then this becomes true. If I take this C, then this becomes true. If we take A, both becomes false and only show will be called. We cannot typecast. In that case, we cannot typecast at all. Right. Next is coming to B1 and C. Instance of operator has a condition. Instance of operand 1 is a reference variable. Operand 2 must be a class name. The condition is it must have a relation. It must have a relation, okay? Relation must. Reference variable and class name must have a relationship. Then only this statement is valid. This statement is valid. Otherwise, this itself gives a compilation error. Now, come to our point. If we put here in B, this one B1C. So if I write here flag B1 instance of C. B1 instance of C. B1 is of which type? B type. And comparing with C. B and C, any relation? No relation. This is statement compilation failed. Okay, check it. Cannot compare. You cannot. Error is compatible types. Incompatible. These are incompatible. You cannot compare. Error, incompatible types. B cannot be converted to C. Compilation fail. You notice this is a compilation error. And other this, what is it is giving? Either true or false. You are able to compare, but it can give a result. It can have a object of that type, or it may not have object of that type. Chance is there, you can compare, but these you cannot compare at all. Similarly here, if we check C1 with B, C1 with B. C1 is of which type? C type. Comparing with B. B and C, any relation? No relation. This gives a compilation error. Compilation fail. Okay. Same error. Reason is same. Reason is same. C cannot be converted to B. So what you understood? Instance of operator is to compare the reference variable and object of particular type or not. Reference variable is pointing to an object which is of a particular type or not. But when that is possible, this statement you cannot do. Okay, this is compilation error. This is compilation error. Other things, this is okay, it will return a false. This is compare is okay, return a false. Comparison okay, true or false. Comparison okay, true or false. Means instance of operator you can use only when there is a chance. There is a chance that A1 can point to A object. A1 can point to B object. A1 can point to C object. In that scenario, you can check. Okay. But can I write, is there any chance that B reference variable can point to a C object? No chance. Is there any chance C can point to an A B object? No chance. You cannot. Okay. But A and B is a relationship. B, A and C has a relationship. So those comparison is okay. Instance of operator of first operand must be a reference variable. Second operand must be a class name. These two must have a relationship, or these two should be in the same type. Then only those comparison is possible. I hope clear with this. You understood. Otherwise, repeat this video multiple times. Okay. So now you understood dynamic dispatch, newly defined method in subtype, how you will call. You need to typecast in case of dynamic dispatch to call the newly defined method. But before typecasting, you need to check instance of. If you are not checking instance of, and if the reference variable is pointing to a different type of object, chances there that you can get a runtime exception called class cast exception. To avoid that exception, you need to use instance of to verify that if it is pointing to a particular type of object, then only you try to typecast. Otherwise, don't. Same case here. But when you are using instance of, you should take care that the reference variable and the class name should have inheritance relationship. Means there should be a chance that it can point to that particular type object. Then only comparison is possible. If you are not, if no relationship, then compilation error, incompatible types. You cannot convert. Right? So this is instance of operator. Any doubt? No doubt, right? Next. Another one. Let us take one more example. Test 162 dot Java 162. Okay. And now we have already seen this operator, equality, right? Binary operator, operand 1 and operand 2 is required. Return type is Boolean, always Boolean, either true or false. And in case of primitive data type, we have seen int a is equal to 10, int b is equal to 99, and if you check, Boolean result is equal to a equality b. It will give false anyway, right? You know that. Result. Test 162 compile. (162) false. If the value is same, it will be true. True, right? What if we do this for a1 new a and a2 new a. And now result, same result only. Result a1 equality, result assignment operator a1 equality a2. What will happen? Means this equality operator we have seen with primitive data type. We are checking that with the reference type. Okay. Now this is a type. Okay, I'll delete these things. These are not required now. Only we need this one. Okay, what I'll do is I'll delete this, and this is Boolean. It will become false. Okay, the result is false here. Compile test 162 and execute. False. What this means, what it is doing internally. We have a reference variable of a1. This is a1 pointing to an object of type A only, 100, 100, pointing to this. A2 pointing to another object, maybe 1040, this is 1040. And when you say A1 equality A2, it verifies these values address. Okay, it is checking 1000 is equal to 1040 or not equal, false. Okay, it becomes false. What if we do like this? Say after this we are checking a1 equal to a2, and after that a1 equality a2. What this statement means? Assign a1 a2 to a1 means a2 value should go to here, this value becomes now 1040, means this starts pointing into this, not here now. So now if you compare, it is 1040 equal to 1040. This gives true. Okay, check this. After that, A1 equal to A2. Okay, and after that again we check the result. Result equal to. Now it should become true. Save and compile. This is because it is like this. Okay, not like this, not this one. It should be, this is correct, but before that A1 assignment A2, like this. Now you compile and execute. Test 162 and it is true. Okay, this is true. Now it is pointing, both is pointing to the same object. Both is pointing to the same object. What if A1 is equal to new B? What you are telling? You are telling that A1, which is pointing to this object, both A1 and A2 is pointing to this one, right? Pointing to this one. Now you are telling A1 is equal to new of B, means create a B object somewhere in the memory. This is B object 1080 and assigning that to A1. A1 is pointing to this. Now this value is not this one. This is 801080. Now you are comparing A1 is equal to A2. A1 equality A2 means 1040 equal to 1080. It will become false. Okay. Now compile again. After assigning this, it will become false. Compile and execute. It is false. Similarly, before that, A1 is equal to new C and comparing. Again, it will become false. Compile and execute. It is false. Right? It is false. Now, what I will do is take another variable. A4 is equal to new of A, new of B, dynamic dispatch, new of B, and B4 is equal to new of B again. Now, if I do this, A4 and B4, it will be false only, right? It will be false only. Compile it. It is false. Oh, not A4, B4. It is false. Similarly, if I take another C4 is equal to new C and doing the same thing. A and C4, it will be false again. False. Notice here, A I am comparing with B, A I am comparing with C. What if we compare B and C? Said, let us do that. B4 equal to C4. First, you need to understand what you are comparing. You are comparing a B type reference variable B4 is pointing to an object C4 reference variable pointing to an object. This is of B type, this is of C type. What is the comparison means? Comparison means you are checking that this is pointing to a particular type of object or not. Both is pointing to same object or not. A4 and C4 is pointing to same object or not. A4 and B4 is pointing to same object or not. B4 and C4 is pointing to same object or not. But is there any chance that B4 and C4 can to point to same object? B and C, no relation. Is there any chance that B and C can point to same object? No chance at all. It can never happen. Similarly, like instance of. In instance of, we have seen operand 1 and operand 2 must have a relationship. That only it can be verified. Similarly, equality operator, when you are using with reference type, that also should have a relationship. Otherwise, this is a compilation error. No chance at all. But so far what we did, it has a chance. A can have an object and B can also point to the same object if the object is of type B. A can point to an object, C also can point to an object if the object is of type C. But is there any chance this can happen? It can never happen. So this is a compilation fail again. No chance. Check it. Compilation fail. Incompatible type B and C. Operand type, bad operand type. Okay, what we seen before. This is this. Incompatible type B and C. This is why we are discussing this so far, okay, to understand this at least. When you are using equality operator, this is actually, what is this meaning is, if I check int x is equal to 99 and string str is equal to hello, then if I say like this, the result is equal to x equality str. Is there any chance that x and str can never be same? X is of type integer, string is of type string. Hello, it can never be same. So this comparison is also not possible. Same thing here. B and C never can point to the same object. So these chances itself is not there. So you cannot do this comparison. This is the same thing. Okay. So this is again assignment operator with, sorry, equality operator with reference type. Any question so far? Instance of dynamic dispatch, typecasting, class cast exception, incomparable type, equality operator with reference type. Any question? No question, right? Repeat this video, very, very important. Okay, if no question, then this is OOPS concept, but in OOPS, okay, we are seeing the members of the class, right? So far in object-oriented programming, members of the class, in that these members we have seen, abstract class we have seen, constructors, blocks, methods, interface, all these things we have seen. So many modifiers, access modifiers we have seen. Next is inner classes. In members of the class, next topic is inner classes. But inner class we will see little later. Tomorrow onwards we will start with the built-in packages, which is lang package. Do not miss the classes. And these were here, from here onwards we will start with IDE. Okay, we will not use the command prompt anymore. We will use IDE. Any IDE we will use Eclipse or IntelliJ you download, make it ready. And next class we will start with lang package. If no question, then we'll leave here today. Thanks everyone. Bye-bye.